question number 20th is about refraction, and it has to do with refractive indices. So we got light travel from the bottom through one layer with this index, another index. So it's kind of like the light rays being bent at each interface, like at each incident point here. So let's see, why do you get it wrong here? So you set up, yes, that's right. If this angle is 50, then this angle is 50 as well. But the angle here should be what? 90 degree minus 50 degree to be 40, right? Okay. And then you have this one theta here and some angle here. Okay. So if you can recall about the Snell law for refraction, we got what? Let's just check off the data booklet again at the wave phenomenon C3. You will see it, N1 over N2 equals to psi theta 2 over psi theta 1 equals to V2 over V1. So V here is the speed of the wave that travel in different materials, right? If you got the speed of light, this is the light, and light is basically like the electromagnetic wave. Travel in different medium. If it's vacuum, then it should be the C. But there's some different materials like water, like oil, then the V will affect the lambda. Okay, the frequency will always stay the same. It doesn't change, but the lambda will change, depends on the media. But in this one, we don't really need to use this one. We just need to use the first part here. For me, I prefer to learn it the other way, like this. Like if I multiply both sides like this, like the butterfly, it will help me to remember it easier. Because whenever I got the refractive index of that medium, I will times with the side of the angle in that medium. So like this one and like this one. Okay, so what is the N1? What is the N2? 1 means that this one should belong to the incident medium. Okay, this is a singular, and 2 will be the refractive medium. So when you got the light ray travel like this at each incident point, so let's call this one is the first incident point here. This is the first incident point. And let's name it like A. Okay, so at the first incident point, the interface between the medium with this refractive index and from the vacuum, so when just 1 here, you can see the angle theta 1 is defined as the angle that is made between the normal line. This is the normal. Why? Because that's the normal that make a 90 degree or the right angle with the interface between the two medium. Okay, you got this one here. This is the incident point. This is the angle theta 1, and this one will be this one here. Okay, again here, this is the refracted ray after it goes through the first medium. So the theta 2 is defined as the angle between the normal line and that ray. So this is the theta 2. Okay, this is the theta 1 at this incident point A. But when you reach to another incident point B here, then the normal line is this one, right? So this one becomes the incident ray at the point B, and this is the theta 1. Okay, and then you have it refracted out here, so this will be like the theta 2. Make sense, right? And now if you got to another incident point C here, then again, this is the incident ray at the C point. This is the angle theta 1, and now you got it out, and it should be the theta 2, right? So what I want to highlight is that you got this apply for each incident point. So we have to make sure which incident point we are talking about here. So you have, this is the N1, okay, so this one should be the side of, oh, so if this is the N1 for you and this is the N2 for you, so you're looking at the point P, right? Point B, sorry, point B. So you got this one is the N1, yes. So this one should be the side theta 1. Is that 50? Oh, so can you see here? It is not 50, it is the angle, right? And this angle is actually just 40. So that's why we make a mistake here. This one should be 40 degree, okay? If you just write 50, we can mistook it as 50 radian. It should have the degree as the unit for the angle here, 40. And now they ask for this angle here. Okay, yeah, fair. So this is actually the theta 2 in this case, okay? Yes, so then we just have to try it again. So 5 over 3 divided by 4, this should be like 5 over 4, and this is the side of this one over the side of the 40. Okay, so you can clearly see that this one should be greater, right? So we can also see that here it's greater. So it should be something that greater than 40. So it cannot be either A or B, right? So let's see. Basically just the arc side, right? So just use the calculator. I'm using one calculator right now. So if I just multiply both sides with side of 40 degree, then we can have this one cancel each other, right? And then this one around 0.80 side of theta. So then theta just equal to the arc side of this one, right? The inverse function of the side function. So just use the calculator. Yeah, I found it somewhere around 53 degree, okay? Something like 53.13 degrees, so that should be C. Okay, so I think the mistake here is just that you mistook the angle. So make sure whenever you apply this one, you have to got an interface, you got an incident point, then you draw a normal line, and then when you got the line rate, if it goes this way, this is the angle theta 1, okay? This is the angle between the line rate and the normal angle. It's not this one, it's this one, okay? And then if you got the refracted ray like this, so then again this one here should be the angle theta 2. So again, that's the angle between the normal line and the ray. So I think that the keyword to solve for this one is that draw the normal, okay? Draw the normal to the interface, and the angle is between the normal and the ray, okay? Yeah, so that's the point. Thank you. Please let me know if you have any question.